close examination of a map of the Earth often results in the observation that most of the continents seem to fit together like pieces of a puzzle. For example, the West African coastline just looks like it just wants to fit into the east coast of South America and the Caribbean, and a similar thing appears across the Pacific. The fit is even more striking when the submerged continental shelves are compared rather than just the coastlines. People had noticed this similarity for many hundreds of years, but it wasn't until the 20th century that somebody wondered if there was more to it than just coincidence that the continents looked as though they were pieces of a puzzle. In 1912, Alfred Wegener, who lived from 1880 to 1930, noticed odd similarities between some fossils, rocks, and ancient glaciers on different continents. He noticed that fossils of the same species had been found on different continents. For example, those of a reptile, Mesosaurus, had been found in South America and Africa, and fossils of an ancient fern had been found in Africa, Australia, India, and other places. He noticed that there are several mountain belts that seem to stop at the edge of one continent and then start again on another continent. The Appalachian Mountains of eastern North America are made up of rocks of similar type and age to those of the Caledonian Mountains of Western Europe. If Europe and North America are joined together, they would form one continuous mountain range. He noticed that the southern hemisphere has many glaciers that support the idea that the continents have moved. Glaciers leave large grooves and troughs in the land they move across and deposit large piles of sediments. Matching piles of sediments and grooves in various southern hemisphere continents indicate that these areas were all once covered by glaciers. Wegener argued that the only way to make sense of these observations was if the continents were once in different locations and have since moved to their current locations. He proposed that the continents were all once compressed into a single proto-continent, which he called Pangaea, meaning all lands, and over time they all drifted apart to their current distribution. He believed that Pangaea was intact until the late Carboniferous period, about 300 million years ago, and then it slowly started to break up and drift apart over the following Devonian period. However, Wegener's hypothesis lacked a way to explain how the continents could actually drift across the Earth's surface as he proposed. It wasn't until the 1960s that evidence was found to explain Wegener's hypothesis. After Wegener's death in 1930, scientists discovered new evidence and began to build on his ideas. In the 1940s and 50s, the ocean floor was mapped using sonar. Sound waves were used to build up a map of the ocean floors, and the oceanic ridge systems were discovered on the ocean bed. In the early 1960s, American scientist Harry Hess proposed the theory of seafloor spreading to explain oceanic ridge formation and activity. Seafloor spreading occurs when magma rises up from below the Earth's surface at oceanic ridges. This material then moves away from the ridge towards continents, where it is ultimately consumed back into the Earth at oceanic trenches. Meanwhile, new material continually rises up at the ridge axis. In the 1960s, drilling of the ocean floor revealed that the oldest oceanic crust is at the continental edges, and the youngest oceanic crust is at the oceanic ridges. In doing this research, scientists discovered that the Earth's magnetic field had reversed many times in the past. At intervals of thousands of millions of years, the north and south magnetic poles switch places. They found that as you moved away from an oceanic ridge, the rocks had locked in the magnetic field prevalent when they were formed. This formed stripes of rocks with the same magnetic field on the ocean floor. By 1968, seafloor spreading and continental drift had been combined into a new unified theory, plate tectonics. The theory of plate tectonics states that the Earth's outer layer is made up of a number of plates that move about on a plastic-like layer of the mantle. Each plate makes up a part of the Earth's outer skin called the crust. You can think of the Earth's plates as being similar to large sheets of ice floating on the ocean. As you can see in the video, the plates are in constant motion and have been for millions of years, and will continue to move into the future. They do, however, move very slowly, with the fastest of them only moving a centimetre or two a year. As the plates slowly come together, pull apart, or slide past one another, they create volcanoes, earthquakes, mountains, and new crust. In the past, the continents have come together to form supercontinents, and broken apart several times throughout Earth's history. The most recent supercontinent, called Pangaea, began to break up starting about 300 million years ago. The process continues to this very day, with Canada and Europe moving apart, and Canada and Asia moving closer together.